Good morning, chat. My name is Penbu. I'm the programming, puzzle gaming, and music making VTuber on Linux, and today we are installing Arch Linux. It's funny because when I started streaming, I figured I wouldn't do this ever, but here we are. Seems like the opportunity presented itself, and people were interested, so we're doing this. How are y'all? I hope you're all doing well. This week, we are doing Technical Debt Repayment Week, because a lot of the weeks in the past month or two even, we kind of skipped out on the technical streams. And I can't be the programming, puzzle gaming, and music making VTuber without the programming part. So, this whole week, so let's pull up the schedule here. Schedule. All up on the website, by the way, if you didn't know. So this week, today is the Arch Linux VM install. Tomorrow we're going to be playing the web security game Natas at the over the wire. Friday we're implementing CAD and Pure Bash. This will be a programming tutorial. You don't need to know anything, and then we're going to cap it off with a bit of Tetris 99 because there's a new theme coming out. This one's not technical, but that's okay. Carmen Cano, and welcome in. I can't wait to hear what programs you use and why. We'll get to that. I don't think I'll end up installing like everything that I have, especially since I am going to be working with a smaller disk, and most of the stuff that I'm going to be using, like for example, I'm not going to spin up an entire graphical session with everything that I use, but we will install a graphical session at some point today, just to show that it does work. So a bit of backstory here. Why do I use Arch? It was about 10 years ago, I think it was 2014, where I first used Arch. Was I had a laptop in university. It came with Windows 7, and I knew that even prior to getting the laptop that I would want Arch Linux, because I had previously used OpenSUSE, the Chameleon one, Chameleon distro. This one. And at the time, it had a slow release. It didn't. I don't think it had Tumbleweed, and I ended up having it as outdated. My dad was the one who was maintaining that installation, and he didn't update it for a while, so I was stuck with some old programs. Can you end each sentence with "by the way"? I'll try to put in as many "by the ways" as we can. By the way. But what do we have? Yeah, so I ended up with some old programs and wanted some new ones, and I found Arch as bleeding edge. So Arch Linux here is, you may have heard of it, by the way. And you know, if you ever meet anyone who uses Arch Linux, that you will know because they will tell you. But the reason I went with it is because it's very customizable. The way you install it, it's famous for having a very manual installation process, although that's no longer true because it does have an installer now. But it's very famous for being fairly manual, and you have to do a lot of things yourself, and that's for good reason, so that you know exactly how your system works. Because the more involved you are in the installation process, the more you know how things work and what to fix when things break. Which is unlike a lot of other popular distros, where that you get an installer, you get a lot of things all at once. Things generally will just work. There are times where things will break, but at least with Arch Linux, they have this great wiki with a lot of documentation. Make this a little bigger. A lot of documentation, and in this documentation works fairly well for other distros too, because Arch is fairly vanilla when it comes to packages. They try to do as few changes as they can. Yeah, so they try to do as few changes as they can to these packages. So anything you learn here is probably fairly applicable to other distros as well. I'm going to drop a link to this in both chats here. I hope my voice isn't gonna die, because it has been feeling a little bit, my throat's been feeling a little bit off this week. So can't die the first day of a whole week of streams. Anyway, so we're gonna install this. I've already downloaded the image. If you want to follow along, it's best that you download this now, because it is 1.1 gigs. So it may take a while to download if you don't have fast internet. Meanwhile, WSL-install and done, you got your terminal in Windows. Yeah, so I for work I have a Windows computer. I actually used to have a Linux Mint installation on it until they swapped out my machine, and then they told me I had to use Windows. But I need a POSIX environment for the work that I do, so WSL it is. But yeah, I basically just live out of the WSL terminal on Windows. By default, WSL I think is Ubuntu, which is fine. It's fine. I think you can. Arch is not a officially supported distro, but you can get Arch on it if you really wanted to. So today we'll be using VirtualBox for our VM software. It's freely available, and we're going to fashion this after my system. So once we get there, this here will be useful. Okay, so we have here the installation guide. If you go down here to documentation, or if you go to the wiki, there's also the documentation link here, installation guide. It all points to the same place. I'm not going to be reading this out to you, but we will be going through the installation process together. Pre-installation, I've already recorded an image, and I've already verified it. So whenever you download something, especially when it's something like an installer, you should always verify that you've downloaded the thing completely and that you've downloaded the proper thing. And one of the ways that you'll see that is either with, I think it has a, yeah, right here, SHA-256. So this is a checksum. But you'll also have many times a PGP signature. Which is a cryptographically secure way of saying that this is what's intended to be downloaded. Or the short of it is, anyway. Prepare an installation medium, we already have, that's nice, so that's going to be put in to the virtual machine, and then we boot the live environment. So before that, we need a machine first. We're going to add a machine here. We're going to call this ArchVM. No, actually, no, sorry. We need to create a new one, rather. We're going to call this ArchVM. I got this ISO image here. Already had it pre-selected. So I had done a test installation a couple days ago. So I do know that this setup at least works. It also knows that because we called it Arch, VirtualBox does have some presets for Arch Linux. Make sure that it'll run fairly smoothly. Hardware, base memory, 1 gig is fine. We only need one processor, so this is fine. We're going to be enabling FE because we are basically any computer that you buy today is going to have FE enabled. So we're going to enable that here. This is as opposed to the old BIOS, and basically the BIOS had very limited scheme. FE is newer, although I think it's been around for about a decade now at least. So we're going to create a virtual hard disk. Is 8 gigs enough? Probably. We're not going to be installing a whole lot, so this is probably fine. I can go up to... Let's go up to 20 actually. I have enough disk space for this. I have 500 gigs free, so this should be fine. Next, an overview of what we have. This should be okay. This is basically just all we had there. All right, and then now we just launch it and hope nothing breaks. Okay, don't need to show you that. Okay, we are also going to go into scaled mode. We can at least see stuff. Those specs are ridiculously tiny. I trust you. Yeah, with the base installation, you don't actually need a whole lot. And Arch can install on pretty small small devices. And it also never had a bad download. It's checksum really necessary. It's a good idea. Well, if you're torrenting an ISO, the torrent comes with its own checksumming, so it's not strictly necessary. But if you're downloading like just as a regular download, it never hurts to do so. For every virtual machine you've made, you need put at least 4 gigs of RAM and 32 gigs of disk. I mean, if you have the specs for it, sure. It is a little bit excessive for what we're doing because we're not running anything too heavy. I don't think, if you're doing a Windows installation, you probably will need a fair amount. But for Linux is fairly lightweight, so this should be fine. I just have to remember, how do you get the there's the menu, okay. In case we need the menu, there it is. I might want to go back to not that. Let's see if I can make this a little bit bigger, because I think it is a little bit harder to see. So let's scale to 150, because we don't need the rest of this, I think. Actually, we can probably shrink the screen too, couldn't we? Couldn't we? Where's my cursor? Yeah, if we shrunk it to like 1024 by 768. Oh well, that's fine. So now we booted into live medium. Put that over there. Point the current boot device to the one that has the Linux installation medium, so that we've done that. When the installation medium's bootloader appears, we've done this too. If you use the netboot image, so fun fact here, Arch Linux does provide a way for you to boot over the network. So you don't actually have to have the disk locally available. You can just have it download the disk on the fly. Obviously, it takes time for it to download, but you can do it. Also, I'm going to pin this this installation guide in both chats here. Let me pin this. There we go. So for any of you coming in late, you can follow along there. Okay, so what do we have here? Now we set the console keyboard font layout, or keyboard layout and fonts. We don't care. Verify the boot modes. We had set this to FE earlier, so we shouldn't need to do this, but we'll check it anyway. I'm going to maybe put that over here, so it's a little bit easier to see side by side. So cats this firmware FW platform size. So this should tell us whether we're in 64-bit mode or 32-bit mode. We are 64, that's good. Computers these days, they're all practically going to be 64-bit. It's very rare that you'll find a 32-bit. And Windows actually, no, I think Windows 10 still has a 32-bit version. Windows 11 does not. But yeah, Arch Linux officially doesn't support 32-bit anymore, but there is a fork that has 32-bit support. Alright, so connect to the internet. To set up a network connection to in the live environment, go through the following steps. We do IP link. And so we see here we have two interfaces. We have LO, which is our loopback, which points to the current machine, and we have ENP0S3, which is an Ethernet connection to the outside. Our cable is virtually plugged in already, so we don't have to worry about that too much. We can verify that our connection is actually connected by doing ping archlinux.org, and we do see a ping coming back. So ping here just sends packets to the server, in this case archlinux.org, and then the server is supposed to respond back with some other packets that we receive. And that's what we see here. Next is updating the system clock. Because obviously we want to make sure that our time is correct. So we can do time date CTL, as it says here, to check the time. It is is that? Yeah, no, that looks about right, I think, for UTC time. I think the last 32-bit machine I found was one laptop I found at a friend's place, and they wanted to check if it had anything of value there. Machine from 2010. I think we still had... 2010 would have been... Actually, when did Windows 7 come out? I think that was like 2010, 2012-ish. So I think that would have been around the time when 64-bit machines would have started getting popular. I actually have... I do have a 32-bit machine, I think. It's a ThinkPad T60. Yeah, a ThinkPad T60 that I got from work because they were giving away some old tech stuff. Pop open the dots file. Dolphin Bird will come in. I'm not sure what you're talking about for the dots file, but do tell me. Okay. So we want to make sure that the system clock is synchronized. This is correct for UTC, so this is probably fine. And then we can set up our our actual time zone later on. Partition the disks. It says here use fdisk-l. I prefer not to do that, actually. I prefer to use cfdisk because it gives you a more graphical way of looking at things. Over here, our screen is a little bit too wide, so I'm going to scroll over there. Select label type. These days, your disks are going to be formatted in GPT formats. DOS format here would have been the older one. If you were working in legacy BIOS, this is what you'd use. If you're in EPI mode, you're most likely going to use GPT. And any modern computer you get these days are going to be their disks are going to be formatted in GPT. The other ones are fairly irrelevant these days. And I think it was from Sun Microsystems and SGI. I don't even know what that is. But we're going to select GPT here. Interesting that both fdisk and cfdisk are pre-installed, yet do the same. Yeah, it has the Arch Linux installer does have a number of utilities that you can use because people like different things, right? Fdisk, I mean, I can show you in a bit, but fdisk is basically a command line, and I am very hesitant to do dangerous things like disk partition in a command line. So I prefer to have something at least a little bit more graphical than that. Before I used to use gparted, which is it was a GUI program, but there is no GUI here in the Arch installer. But I found out that cfdisk was available, which is plenty graphical for me. I'm going to adjust this so that it's not that anymore. Maybe scale it back to 100%. Okay, we still have a little bit of horizontal scrolling there, but that's okay. Maybe move this over. So we're going to create our partitions here. So you gparted. Yeah, I actually haven't used gparted in a very long time. I've since switched over to cfdisk because it's easy enough. Yeah, okay, what do we have? So dev SDA, which is the only disk that we have in our machine right now. And if we are going to go based on what I have here, gonna shrink the font here a little bit. I'm going to shrink the font even more. Okay, actually this is fine. So in my final, like currently running PC, I actually have 3 disks. I have one hard disk, another hard disk, and an SSD. This SSD is my main disk. It has my operating system and some data in it. And the other ones are just for data specifically. The SSD is now then partitioned into 3 main partitions. One is the boot drive, the boot partition. Another one is, I think this is swap. No, this is not swap. This is alt boot, right? I have another partition for storing ISOs that I can boot to at boot time for things like system recovery. It means that I don't have to have a disk around. I can just boot directly to here, assuming that the bootloader is still usable. Yeah, so I got 8 terabytes disks some time ago. I actually had installed it. So actually, this is the reason why I'm doing this stream here, is because when I got the 8 terabytes drives, I was running out of space on my home partition for all the streams that I'm recording, because all the streams, 3 hours takes up about 10 gigabytes. And so I needed extra space for it, so I got a couple of 8 terabyte drives so I can have more space. But I figured I'd get 2 of them so that I'd actually have a little bit of redundancy to make sure that if one of them fails, I don't lose all my streams. So yeah, what we have here is 3 main partitions on the SSD. One of them is the boot partition, which is the SP. The second one is one where I house all my my recovery ISOs, and then the other one is where everything else lives. 8 terabyte drive to home server pipeline. I do kind of want a home server. Okay, no, that's not true. I have a home server running. It's if you remember the ThinkPad that I mentioned that was that I had in university. I'm actually using that now as a home server. It is connected to a couple of external hard drives that I'm using as storage, like network attached storage. But it would be nice to have a proper NAS and have like actual multiple disks and stuff. Question, I thought we were using a virtual box machine for this. Can you access your main hard drive from a VM? Right now I'm showing you, I'm running this on my current machine, just so we can look at the partition layout that we're going to look at, at making. The virtual machine is still over here. We haven't done any partitioning yet. We're just looking at the partition scheme. And so what this is going to look like, we open up ExcaliDraw here. We have our disk. And then that is going to be broken up into 3 partitions. That's going to be one here. Maybe another one here. And then there's going to be this big one here, where this is going to be LVM. And that's going to contain a number of logical partitions inside. We're going to have like root, home, our var, home, or whatever else we want in here. So it's 3 main real partitions, and then one that houses a lot of logical ones. And I'll explain why we want to do this in a bit. But for now, in our case, we don't actually need a very big partitions. Yeah, I don't think we need very big partitions here, so I think we're going to keep this as 512 megs. And then this, I'm probably going to make this 2 gigs so we can fit 1 ISO in there. The Arch Linux ISO I think is right now just a little bit over 1 gig, so we're going to make sure that we have more space for it. And then the rest of it we allocate to, so we allocated about 20 gigs for the entire disk. That leaves us with about just a little bit less than 18 gigs. which should be enough for the rest of the system, I think. So, okay, so given that, right, we said 512 megabytes for the ESP, which actually this is a little bit high. We can go a little bit lower. Let's see if we can see what this says. Yeah. Yeah, this is fine. So we're going to create one for the ESP, which I'll explain in a bit. This one has type FE system, I think. Is that correct? Yeah, I think this one is called FE system. And then we have another one that is 2 gigs. This one will have type Linux file system. That's our, actually no, this one will have type, what do I have in my, in this one? This one has, no, I do want this one. A little bit messy, but this one is ext4. Okay, so we do want Linux file system on that. So if you are familiar with partition tables, basically the disk can be broken up into multiple sections, which are called partitions, and each of those partitions are labeled with a certain type that tells it what's contained in it. In this case, we're telling it that it contains a Linux file system. The other one earlier, we said that it contains an FE system, which is used for booting. And then the rest of it, we're going to take up the rest of the free space. And then this is going to be of type Linux LVM, which is our logical volume manager. That allows us to have, we go back to the Excalibur draw. Right, this part here will be LVM. By the way, if any of you have any questions, please feel free to shout them out in chat. I will do my best to answer them. Okay, so these are our 3 partitions that we have. So we're going to write now, write partition table to disk. This might destroy data. There is no data on this disk. We are okay. Are you sure you want to write the partition table to the disk? In this case, yes. We have to type in yes, because it is a dangerous operation. They want to make sure that we know what we're doing, and we have to type in yes, in words. Okay, so now we can quit that. We're going to go back to the large view. So now if we do the same ls block dash f, right, we have, in this case, SDA. You notice that in my real output we have SDA and we have SDB and we have SR0 and NVMe. These are because the way Linux identifies the different drives is based on how they connect to the motherboard. So in this case, NVMe connects to the motherboard. The drive is an NVMe drive, so you get that. SDA is a SATA disk, and then even older, you'll have HDA, which is connecting through the IDE connectors. I haven't seen those in quite a while, so mostly you'll see these days either SDA or NVMe. But in this case, our hard drives are connected with SDA or with SATA connections, so we have SDA here. And then because we're in a live environment, we also have loop 0. The ISO disk that we're running on, the installer, is on, yeah, so it's running on the disk, and it's a loop back connection. So if you swap drives or connectors, they get different names. Yes. So I think they are based, are the names and the letters that they get that are connected, they are assigned in order. They may or may not be stable, but I think it's in order of discovery. Right, so A will be the first one that's discovered by the system. B will be the second one. And then if you have, say, if you have an NVMe drive and then you put it into a SATA adapter, so you can put it into a SATA slot, the system will see that as a SATA drive, not an NVMe drive. Okay, so these are our partitions, and then it says now we need to format these partitions. So we look at what we have here. This is going to be a little bit messy because of this whole thing. Maybe we can shrink that a little bit. Hopefully that's still something you can see. It is a lot of information here, so you'll have to bear with me here. The FE partition is a VFAT drive, or a VFAT file system. The alt boot system that we have is ext4. ext4 is a fairly good default Linux file system. And then we're going to set up LVM on the third partition here. I'm going to see if we're jumping ahead a little bit. File systems, create a file system. So Arch Linux used to have a beginner's guide that did a bit more hand-holding. They since got rid of it. Now you have just the installation guide, and now you have to click through to most of these pages, which I understand the motivation for. It just kind of, I think as a beginner going into it for the first time, it might be a little bit overwhelming with all the choices. Okay, I'm just going to ignore this, and I'm just going to walk through this as I would normally do it. I will have to look at the stuff for FE though. It's probably in the installation guide somewhere, but it's FE. The FE system partition, there it is. So as part of partitioning, you do need an FE system partition. And this partition basically is where all your boot data is held. So this is where the operating system puts its files to say that this is the part that you should boot first, and then that program, it's a very small program, that program will load the rest of the operating system. More or less. So this label type GPTs, we've done that. We created a partition. We have, we're going to ignore MBR because we don't need that. We have GPT. And we want to be doing this, the makefs fat32 on the partition that we have created for it. So, makefs.fat. Fat here being the file allocation table file format that Microsoft has created. This is the file format that you'll get in a lot of smaller flash drives or SD cards. It's very versatile, or a very common file system, and it's very widely supported. But that said, it is also fairly featureless. I mean, the file system has features. Just comparatively to other file systems, it's very low featured. So makefs fat f32. We want to do this on dev SDA1. And so now we do ls block f again. We now have a fat formatted partition. However, I think I did name mine, and I think I do want to make sure that we name this one too. So man makefs.fat. We look at the man page, we should see a flag here for naming the thing. I think it's called label. So we want -n here. We're going to rerun that, but now we want -n. We're going to call this FE. Redo it on dev SDA1. And so if we do this again, we now see that we have a label on SDA1. And these labels are useful so that we can identify what these partitions are just by looking at them. They're basically names that you can give the partitions, and they're useful so that you can give them human readable. Okay, so we want to do the same thing also for SDA2, but in this case we want to make fs.ext4 look over here. Very similar thing. Makefs here, mkfs is the utility for making or for formatting partitions. So when you partition a disk, all you're doing is sectioning it and saying that this space is reserved for this bit. But to actually use the partition, you have to put a file system on it. You have to format it. So in this case, the FE partition has to be formatted as FAT. And then for the other ones, you can format them however you want. In this case, for the alt boots, I think it's also -N, or is it -L? No, -L then. Label -L. Okay. Sometimes these all take different flags, so you do have to check the man page just to make sure you're doing it right. This one we're going to call alt boot, and we want to put this on dev SDA2. All right, so to verify that, yes. All right, so now we have SDA1 as our FE partition, formatted as FATS32, and we have SDA2 as our alt boot partition, formatted as ext4. And then for the last one, this is where things we're going to veer a little bit off from the installation guide, and we are going to set up what is called LVM. And so LVM, what this allows you to do, if you remember back in Excalidraw here, right? We have this partition, which is a real partition, but we also have this little container here with partitions inside. This is LVM. LVM, the Logical Volume Manager, allows us to virtually create partitions, and that means that we can change the size of these partitions however we want at any time. Yeah, this is the hot take part. Although I don't think this is too much of a hot take. LVM is pretty common. If you didn't have LVM, and I know some people don't like LVM because if you flip a bit somewhere, maybe the whole drive ends up being corrupted or whatever. It's a little bit extreme, but there is a little bit more risk with virtual partitions than real partitions. But it makes up for it in flexibility. Because with real partitions, say if you wanted to resize this partition, you would have to move this over, but to move that over, you'd have to move, shrink this. I'm going to copy this actually. I'm going to copy this. And we can pretend that this isn't here. Nice, select please. Can I select please? Okay, whatever. So say you wanted to grow this partition over here. What you would have to do, and because you need free space for this to work, right? So you have to shrink this partition. So that shrunk here. This is all free space now. But then you also have to move this partition over. Right? You move it over to the left or to the right. Can I select two at once? Okay. You have to move that over to the right. But that also leaves a hole here. So this is now the free space. But then you also have to move this over so that you make free space on this side. So this is now the free space. And then from there, you can resize the partition so that it takes up the entire space. That is a lot of moving data, and especially if you're on a hard disk, this is very slow, because you have to have moved all of this data over to the right, only to make more room here. With LVM, all you have to say is you want more space, and it'll just give you more space. So it's very quick, very easy, because it's all it is basically a table that tells you how large these things are, and where they are. And you can do a lot more advanced things with LVM too. Like, for example, a logical volume, which is the equivalent of a virtual partition, can actually be larger than the amount of space you have in LVM. This is called thin provisioning. And this is safe-ish if you're never going to have data in there that's going to exceed the amount of space here. There are use cases for this. I personally don't have any for them, but it is something you can do. But yeah, this is why I've had to do a number of partition resizes over the 10 years that I've had Arch Linux, and every time that so I've started actually with just doing regular manual partitions, no LVM. And my laptop had a hard disk, like a spinning hard disk. That was slow. What I've learned over the years is that you can do it. You can think about the partitioning scheme all you want, but you're almost never going to get it right the first time. So you may as well, if you can afford it, put in LVM so that you can change that partition scheme later. Now, I think for every machine that I've been on, I've had to change the partitions at least once. And every time that I've had LVM on it, it's been extremely handy. On this machine, I actually have, because I'm not dual booting, so my two laptops, the one that's my first one and then the one I'm currently using now, they're both dual boots with Windows, so there are certain things that I put in there that require a hard partition so that we can share data with Windows. This one, my streaming PC, is all Linux, so that allows me to put the entire system on LVM, I mean minus these two parts, but essentially the entire system on LVM and make use of that maximum flexibility. But anyway, getting back to installation. The way this works is that you have physical disks, which will be the partitions. Then you have the volume groups. We can draw this out. So we're all the way down here. All right. So say these are the. Say this is our disk. Right. And then we have partitions here. We have another. I'm gonna lock that. Another partition here, and then we have another partition here. That I guess takes up the rest of the space. With LVM, you can say that these two partitions belong to a volume group. So this is a volume group here, and it spans these two partitions. In our case, we're only going to have one that spans one partition. In this case here, as we have here, but you can have a volume group that spans multiple partitions across the disks even. That's where it's most useful. Scientists were too worried about if they could that they never thought about if they should thin partition. Yeah, you know, I'd have to look it up, because I know there are legitimate use cases for thin provisioning. I just don't know what they are. But yeah, and then on top of that, we have the logical volumes, right? So these are the virtual partitions on LVM, like that. So, for example, you can have these three logical volumes on top of two physical volumes under one volume group, and it just works. You don't have to worry. So these logical volumes don't have to worry about the backing partitions. Or for example, if these are on two separate disks, then the data is shared between those two disks depending on whether in what kind of RAID configuration they are. You can have them just shared, or you can have them mirrored, and all whatnot. If you look down here, we are actually going to attempt that later on. Hopefully we have time for it. It has been an hour, or almost. We haven't even installed this thing yet. But hopefully so far it's been informative, because that's really what we're getting after here. So here, what are we doing? We are installing LVM. We're going to skip over the advantages and disadvantages. You can read that all on your own. Oh. Hope I didn't paste anything that was sensitive there. I don't think so. But yeah, if you want to read up on that, feel free to. Make sure the LVM2 package is installed. We have that in our installation disk. So we want to create a physical volume on SDA1 or SDA3 rather. Right over here, the biggest one. So if we go back to the wiki, expand that a little bit. We want to do pv create dev SDA3, and so this is in effect formatting for that partition. With the other ones, we formatted it directly with a file system, but in this case, for the SDA3 partition, we're formatting it with an LVM physical volume, sort of. So we now check to see that we have indeed created our physical volume. We can skip growing and shrinking because we don't need that yet. We can skip all that. And then now we have the volume group. Remember, the volume group is the little layer in between. So VG creates. In this case, I like to have my volume groups named with VG for volume group, and then the host name, and then a number. The first one being 00. So we are going to follow the same format here. So VG arch VM is what we called it, and then 00. And we have that on dev SDA3 because that is our physical volume. VGs for verification that we actually have created one. And we're going to skip this for now because we don't need that. And then we can activate the volume groups to make sure that LVM knows that it's a thing that it can use. The VG change -a y VG arch VM 00. Now, it's often a bad idea to blindly use commands that you don't know what they're doing. In this case, -a, if you look at the top of the flags there, -a stands for activate, which is what we wanted to do. And then Y says, yes, do activate them. Alright, the rest of this we can skip. And we can go down to the logical volumes, which will create our actual usable partitions. So in this case, we're going to be a little bit looser here. We don't need as big of a home partition as I have here, but we will want some roots. We'll want some bar, and we will want some swap as well. The proportion of this I have not actually thought out. I hope we can get by with only a little bit. LV creates. We don't actually need a whole big home partition, so we could probably skip out on that a little bit. So I'm going to say 10 gigs. We have about 17.5 gigs for our partition. Actually, I'm going to make this 8 gigs. I think originally it only needed 8 gigs, so we can probably have less than that. So that gives us a little bit over half for the actual system. This is VG hash, or not hashda, VG arch VM00, and this is the name we're going to give it. I usually for this one give it LV for logical volume, and then whatever it is that I'm using this for, so LV root in this case. Do we need 8 gigs on this? That's probably fine. Then we're going to create another one for our var partition. So the root partition is where the operating system goes. The var partition is for some of the auxiliary files that it needs, particularly to do with logs and like Pac-Man caches, or like for packages and stuff. If I ever make a Pokemon ROM hack, not likely, I'll name the PC as Penbu's PC, if you'd like to. So if you have a lot of machines, it's useful to have a naming scheme so that you aren't stuck thinking about what to name your PCs for a day, although that could still happen. In my case, I have mine all named after Steins Gate characters. So one of my I think the main computer that I use right now is called Hashida, named after the Hashida from Steins Gate, the hacker guy. And then this one, this PC that I'm using is called Amadeus, after the program in Steins Gate 0. Yeah, that is why it's Amadeus. It kind of goes well too with the well, I compose, right? It blends well with that too. I have a little bit of plausible deniability, but now that I've said it, I don't think I do. And then my phone is called Kyoma, like holy and Kyoma. Okay, so this one I think we can get away with 2 gigs. So this gets us to 10 gigs. So this will be LV var. And then we also wanted a swap partition. That one, I don't actually need a whole lot. I'm just going to give it 1 gigs. Actually, even that's probably a lot. But considering that we gave this thing 1 gig of memory, so only 1 gig is fine, I think. And then the rest of the amount is going to go to home. And that it's going to go to 100%, or not actually 100% free. I should finish Steins Gate 0 and gotta dust the PS Vita. I actually haven't played any of the visual novels. I've only watched the anime. Well, the anime is good. I like both of them. The first one I think is a little bit slow burning. As somebody who is fairly patient, I can go through it pretty easily, but I've mentioned before that I used to run an anime club at work, and Steins Gate, considering that half of that stuff is very hard to get somebody through unless you set them down and make them watch it and hype up the rest of the series. We managed to do it. I managed to hype them up enough that they wanted to watch, and it was a fan favorite in the club, so it was definitely worth watching. Okay, we actually don't want 100% free because I do want to show off another feature here. I think I want to leave. Sorry, hold on. VGs. LVs. So we have 8 plus 3 is 11, and we have 17. So we can go up to 16, I guess, and leave a gig and a half free for some stuff. Actually, I can just make this 8 gigs too. No, let's make this. There's nothing in my home directory, so I'm just gonna make this 4 gigs actually. So LV creates -L 4 gigs VG arch VM00 and LV home. Actually, even this is too much. I'm actually just not going to have anything in here. 2 gigs is fine. This is the problem with coming up with a partition scheme on the fly. And actually, it took me a while to get to settle on the one that I have currently in my PC too. And granted, I did have a lot of learning from what I had in my previous computers, but still, it does take a while to get to an actual good partition scheme. I'm going to drop this down to 1 gig because we actually are not doing anything in there. Later on, if we decide that we're going to use this for something else in the future, we can always enlarge the disk. The visual novel is so much fun too, especially with the different routes. They're very different from what they show in the anime. Soundscape is what got you into VNs, and that changed your life. Yeah, I've heard this. I've heard the visual novel is very good. Although I also have heard that you can't really stream them past a certain point, otherwise the creator will copyright strike you. Okay, LVs gets us these 4 partitions rather, and then VGs will show us this, and we have about 5 gigs free, and this is intentional because LVM what it allows you to do is do things like snapshots, where you take a snapshot of the logical volume so that you have a snapshot that doesn't change, and you can revert back to it later. And I find this very useful for things like system upgrades. Are we going to use it here? I don't know. But it is useful to have a little bit of free space there. The rest of this is good. I don't think we need to do that. We don't need to resize anything. And then snapshots and stuff, we don't care at this point. But now if we do our ls block again, if I can spell it right. Alright, so now we have SDA1, which is our FE partition, SDA2, which is our alt boot, which I still will have to show you later. And then we have SDA3 containing our 4 LVM logical partitions, root, var, swap, and home. And then now we can treat the 4 logical volumes as partitions themselves. So in this case, we want to do, we notice here we have root as btrfs, var as ext4, home as btrfs, and then swap as swap. We'll start with swap because it's the easiest. If you create a partition for swap, initialize it with make swap that. So this is very easy. Actually, we do need to see what the label is, so -L for label. Move that up there. So make swap dev slash vg arch vm0 lv swap. So you can address these logical volumes like this. Wait, we wanted the L. -L swap. Do we really need swap? I mean, I gave it 1 gig. Strictly speaking, we probably don't, because we're not running anything super heavy on it. But even if you have, so on my system, I have 32 gigs of memory, but I still have swap. And the reason I do that, 1 is because I want to be able to hibernate. 2 is because if my system ever does end up using all of the memory, which has happened sometimes, then it has somewhere to swap to and fall back to. But 3, even if you do have a lot of memory and you aren't going to be, and you aren't filling it up, a swap allows your system to free up that memory for things that it would use more often. Right, so it allows you to swap. It allows the system to swap out very rarely used pages in favor of more recent caches, or sorry, more frequent pages, or file system caches that you'll actually need more, or things like that. So even if you have a lot of memory, it's very useful to have swap so that your system is a little bit more optimized. Same reasoning goes here, but also because we're working with a very small amount of memory, swap is useful to have. Okay. So that was a swap, and then now we're going to make with btrfs. So btrfs here, instead of ext4, the reason why we want to use btrfs here, it is a file system that has is a modern copy on write file system. And this is in contrast to ext4, which is a very mature journaling file system. The difference here is that a copy on write file system like a btrfs or ZFS or what are the other ones? There are a bunch of other ones there. What it does is that instead of writing the data in place and overwriting the data in place, it writes the data somewhere else and then leaves that original data in place. And then once it's done writing, it then swaps over the pointers to the new place. So this means that because you're never overwriting the data in place, if a failure happens, you're either always at the new data or you're always at the old data and never something in between that's corrupted. So it's a lot safer in terms of data integrity. So we have this already. We want to make sure that we create this makeFS btrfs -l root dev / bg archvm lv root. All right, so we created the btrfs partition there, and we also create home partition lv home. Very similarly, also going to be btrfs. btrfs meaning B-tree file system, I think. And also having the copy on write guarantee means that you can do things like snapshots, where similar to LVM snapshots, basically the data is it doesn't change for the snapshot, but you can still write to the disk. Okay, so that is all we're really going to be doing with btrfs. I have this in place particularly for the snapshots, but also because of the data integrity thing. Because it's nice to know that my data won't be corrupted because it does have checksums and all that too. At least not because of the file system. So yeah, those are the two reasons I have btrfs. Data integrity and snapshots. Snapshots are very useful for system upgrades because it means that I have basically a save point for if something goes wrong, I can just restore the snapshot and everything should be good. Okay, so now we mount the file systems. Mounting, oh, actually no, we missed one. makeFS.ext4 -l var dev bg archvm lv var. And the reason why I have this as ext4 instead of btrfs is because btrfs doesn't do well with a lot of small files. ext4 works fine for that. So I prefer to have this ext4 on top of LVM, so we still have snapshotting, but it's more performant than btrfs because ext4 can handle a lot of smaller files. Okay, so now we mount these. Mounting basically means making the partitions and their contents, or sorry, the file systems and the contents available so that we can write stuff in it. So we want to mount the root partition first. So that'll be dev vg arch vm 0 lv root. And we want to mount that under mount. And then we want to create any remaining mount points under mnt. So that's mnt slash boots and home. Did not mean to click or to press that. We have let's bring that back up. Right, we have partitions for our boot drive, that's SDA1. We have partitions for var and home, so that's the LVM partitions there. And so we do that. Under the mnt directory, we create directories boot, home, and var. And to show you that we have created them, there we go. And so then we want to mount each of those partitions onto there. So we mount dev SDA1 to mnt boot, mount dev vg arch vm0 lv var to mnt var, and lv home to mnt home. And it also says here, if you created a swap volume, enable it with swap on, so we're going to do that. Swap on dev slash vg arch vm lv swap. On the topic of swap, actually I should probably explain what swap is to begin with. Swap is effectively memory on disk. So as I explained earlier, if your system runs out of memory, like actual RAM memory, or if it's doing some optimizations where it wants to page things out and take like memory pages from RAM and put them into swap, swap is basically slower memory, but usually you have more swap available to you. And swap, you can either make them swap partitions like what we have here, or you can make them swap files, where it's basically a file on a partition. They're mostly equivalent in terms of performance these days, so it doesn't really matter. In the case where we have LVM, to me it doesn't really make sense to have a swap file because you can just create an LVM partition and make it as big as you want or as small as you want and resize it as you need. The flexibility of the swap file is that you can resize it whenever you want, but then you can do the same thing with an LVM partition too. So to me, it doesn't make sense to really have a swap file unless you are scoping it to a very specific disk for certain reasons, and like specific operating system too. Okay. Installation. So now we've mounted everything. We scroll to the right here, and then we have all these mount points. I think that is everything. Yes. Packages to be installed must be downloaded from mirror servers, which are defined in etc pacman-d mirror list on the live system after connecting to the internet. Reflector updates the mirrors. Sure. So, we're actually going with the actual installation process here. This is the part where we do the where we actually grab all the packages and install them. So packstrap-k mnt base Linux. In this case, I don't use Linux. I use Linux Zen because it's better for desktops. And it says here you can substitute Linux with a kernel package of your choice. In my case, it is Linux Zen. Linux firmware. We have to make sure we get the correct firmware for that too. Gotta make sure that, okay, hold on. Okay, actually no, it looks like it's just Linux firmware. There's no special one for that specific kernel. You can omit the installation of the firmware package when installing in a virtual machine or container. I'm gonna install it anyway. I don't think it hurts, so we're gonna do that. The base package does not include all tools from the live installation, so installing more packages may be necessary for a fully functional base system. To install other packages or package groups, append the names to the packstrap commands above, or use pacman to install them while chrooted into the new system. Microcode we don't care about because we're in a VM. User space utilities for file systems. Utilities for accessing and managing RAID or LVM. We do need this because we do have LVM, so that's LVM2. And we also need the btrfs utilities that we had earlier. So btrfs progs. Progs here short for programs. Where's my cursor? Special firmware for other devices not included in Linux firmware, sure. Software necessary for networking. I think we can probably skip that for now. I mean, DHCP client is probably going to be necessary. Networking is always a bit of a pain whenever I set these up. When I first installed Arch Linux, I was actually installing on the Edge Roam Wi-Fi network, which is an enterprise WPA2 setup, which is significantly harder than if you were doing it on your home network or if you're plugged into Ethernet, because it requires a lot more setup, like getting certificates, signing in with your specific username and password, whereas with just a regular home network, all you have to do is pick out the SSID and then put in the passphrase, and then you're good. With Ethernet, you're plugged in, it all just works for you. And that's the case that we have here. We have basically a virtual Ethernet connection. Console text editor, we're going to want to install Vim, because Vim isn't installed by default. And anything else I think we can install on the fly. I think it's DHCPCD is the one that I have. Actually, no, I have an netctl. But also we don't care because we are plugged in through Ethernet, so we should be okay. So now we've started the installation, and we need to go over here. The packstrap basically is our bootstrapper. Wait, did I do this correct? Yeah, okay, should be fine. Now it's all it's doing is it's downloading all the packages, and it's now going to install all the packages. This is going to take a bit, but not too long because it's only 133 packages. So I guess while we're here, have any of you installed Arch Linux before? And if so, how do you find it? Do you like it? Do you not like it? Average Arch update, yes. I probably have a couple. Do I have a couple thousand packages? Is that true? Yeah, how do I count this? I think. WC-L. I have 2,148 packages installed on this system. And on my personal laptop, I think I have even more than that. I have 3,256 packages on my personal laptop. And actually, my personal laptop's Arch installation is a little bit broken because, I don't know, some update broke something, and I have too many AUR packages, and I need to go fix all that. It doesn't help that I haven't updated that thing in months. So I think the last time I updated was sometime late last year. And a lot has changed since then. So I have to go chase down what some of the changes might have been and fix those. That's why you should update Arch fairly often, so you don't run into that. My other laptop actually is also running Arch. That was the first one, the one that I had in university. I don't think I've updated that since before the pandemic. Probably got a bunch of security issues in it, but yeah. That one's going to be a very big pain to upgrade, because that means having to go stepwise through the Arch Linux archive, going through the years, you know, upgrading like a couple months at a time, just to make sure that things are okay before it can get to the present. But I do want to make sure that it does get updated eventually and not just fresh installed, because there is some pride in the longevity of your Arch installation. That one was from 2014. This one in my personal laptop I think is from 2018, and then this PC here I think it's just been a little bit over a year, maybe 2 years. No, I think it's just been about a year. So I got it back in, I think, March. I set it back in March last year to prep for streaming. And it is now June, a year later. Okay, so running in CH roots, so this is fine. We've pack strapped the whole thing. Now we configure the system. We can create an fstab file. So fstab stands for file system table. It basically tells the system what to mount at boot time. So in this case, we have the script here called gen. Look this up. Gen fstab dash. In this case, it says -u or -l to define by UIDs or labels respectively. I prefer to go by labels because it means that if I have to reformat a partition or swap things out or whatever, I can do so without having to change my my fstab. For external disks, it makes sense to use UUIDs, which are unique IDs attached to a partition. To a file system. So we go back here, right? These are the UUIDs for these file systems. If you reformat the file system, you get a new UUID. So you can imagine a case where you're fixing something and you reformat the partition, and it happened to be, say, your home partition or something, but you didn't change your fstab because you forgot. And now things are broken because, so let's say it's the var partition or something. But anyway, things are broken because it didn't get mounted because fstab didn't know it existed. But with labels, as long as it has the same label, then it'll mount just fine. So this is what it would generate. And we want to write that out into /mnt etc fstab. Right, so it says here that we have our root partition, we have our FE partition under /boot, we have our var partition under /var, home under /home, and then swap under just a swap. Next is to arch ch roots into /mnt. And now, if you notice, the prompt has changed. And that is because we're now in a ch root. What it essentially means is that ch root stands for change root. And that says instead of the root file system where we were before, go into this directory and pretend that that directory is the root directory, so now the slash. And in this way, when we ch root, we are essentially masquerading as being in the system that we just installed. Arch ch roots is a wrapper script around ch root. It adds a bunch of nice mappings for things like devices and whatnot. But that ch root by itself is essentially that. Time. Set the time zone. All right. Oh, go back there. So the closest time zone to me is America/Toronto, Eastern Time, Canada. User share zone info, Americas/Toronto. And we put that under ETC/local time. Just to give you, you've probably seen these in various inputs or like select boxes before. But I think this is the, was it the, is it ANSI or ANA or something like that? Basically, it the world is broken up into a number of regions, and then those regions, in this case, for me, America being the Americas, not necessarily the United States. Each of those then ends up with a city, and then you're supposed to choose the closest city to you that represents your time zone. In my case, Eastern Time in Canada would be represented by Toronto. I mean, I suppose there's Montreal too, but I'm not in Quebec, so. And the city matters a little bit because different regions will have different rules for daylight savings time. So you want to make sure that you pick one that has the correct daylight savings time. In the case of Toronto and Montreal, I think Ontario is looking to implement permanent daylight savings time if Quebec and New York also do that. So I think people are just waiting on each other to actually implement it. And then it says here, once we've done that, we do HW clock sys to HC. So that would be setting the system time to the hardware. I always get this confused, actually. I don't know if it's setting these. I don't have man pages because I didn't install them. Hold on, let me install the man pages. Man DB, man pages, and tech info. It says it right here. Yeah, that's fine. So do that again, man HW clock. Or do I not have less? Install less. Oh no, less is already here. We ran sys to HC. Set the hardware clock from the system clock. So basically, the system clock is what's running in our VM right now, and then your PC maintains a hardware clock. So if you go in the BIOS, you see a time. That's the hardware clock. And then this is important because the hardware clock can drift from the real time. So there is a file here called ADJ time or just time that tells what the offset is at the time that the system booted, or something like that. Now, we are also assuming that the PC's hardware clock is in UTC, which is the sensible option. But that's an option because Windows usually sets the hardware clock to local time, which means that it has to update every time there's daylight savings time. Linux by default has the hardware clock set to UTC. You can change between the two in both operating systems. Usually for me, if I dual boot, I have the hardware clock set to UTC, and then I have Windows set to recognize that. But in other setups, I think Ubuntu by default leaves the hardware clock in local time and then just adjusts its expectations to be in local time. All right, so we have that. And we also want to set up NTP. System D to time sync D is probably fine. NTP here. Actually, cronny I think is what is that what I use? I think I use this one. Let's put that in here. Cronny. NTP, Network Time Protocol, is basically what allows you to update the time from the internet so that you always have the correct time. So we're going to install cronny here, which is very popular time syncing or NTP syncing service. And it's particularly friendly for systems that are not online all the time. Things like laptops or even this VM, because once this is shut down, we're probably not going to touch it until the next stream. So cronny is fine here. Do we need to configure this? I don't know. It looks like it has sensible default, so we can probably just leave that as is. Okay, so next topic here is localization. Localization, it refers to all your language files. So if you're in a language that's not English, your localization here will help. We have to edit etc locale.gen and uncomment enus utf8 and anything else that we need. So I'm going to, because I am in Canada, I will also comment out the Canadian one. There one for C. Oh, I think I got rid of the C one. Any other ones that you might want, you can always just uncomment these out too. There's a lot of languages here. Not everything I think is implemented, but at least if they are, then they're available here. We really wanted to, and I'm not going to for today. We could enable Japanese, for example. But yeah, in any case, you usually want to enable the UTF-8 locales, because those are a little bit nicer to work in terms of... Okay, so we're going to write and quit that. And then it says we run locale gen, which will create the locales based on the ones that we uncommented out. So we have ENCA, which we uncommented, and we have ENUS also uncommented. And then we are going to create etc/locale.conf. So actually, hold on. Yeah, this is fine. Lang equals ENCA for us, UTF-8. And actually, I'm going to install ED as well. Just to make things a little bit easier when I don't actually need full Vim for. ED here is the text editor, the standard text editor. You work with it in a command line. One of these days I want to do a like an ED tutorial, but I do have to figure out how to do that, because I don't know, teaching a text editor requires material. Set the console keyboard layout, make the changes persistent. We did not do that earlier, so this is fine. Network configuration. Create the hostname file. So whenever you have a PC, you should always give it a name, because this name is used in a bunch of other places. In our case, we call this thing ArchVM. So we're going to put that in etc hostname. Complete the network configuration for newly installed environment. Include installing suitable network management software, configuring it if necessary, and enabling a system to unit starts up. So I think at minimum we probably just need a DHCP server. our client rather. DHCP is what allows you to obtain an IP address automatically without you having to set it up yourself. Because there are two ways you can get an IP address from your router. You can either get it statically configure it, so you always have the same IP address, or you can use DHCP to have the router allocate one for you. They used to want netctl. Hold on, I'm gonna see what I have installed, because network configuration, every time I do an Arch Linux installation, the network stuff always fails the first time I reboot. Okay, so I have that, but I also have netctl, right? I do not have netctl. Okay. So on this PC, which is a better representation of this VM, I only have DHCP installed. So we're going to install that pacman-sdhcpcd for DHCP client daemon, something like that. I don't actually know what that stands for. Actually, I don't know what DHCP stands for either. DHCP. Dynamic Host Configuration Protocol. That makes sense. So yeah, your routers will more often than not, like almost certainly, have that enabled. And if it doesn't, you probably did that yourself. I'm also going to install OpenResolve. It says here optional dependencies. I am not sure if we need that, because the resolve conf is usually fine, but you know, whatever. I'm not going to take any chance for this one. Okay. Init ramfs. We probably don't need, actually, hold on, we do need this. Because it says for LVM system encryption or RAID, modify make init CPIO and recreate the init ramfs image. So init ramfs is basically the reasons why it's called init ramfs is it is the initial in RAM file system. So this is what gets unpacked into RAM when you first boot, so that things can actually work, and then from there it can bootstrap the rest of the, or it can boot the rest of the operating system. So the init ramfs has the necessary modules and stuff that you need to work with the rest of the file, the rest of the system. So in this case, we have LVM, which requires its own module. So to make, all right. That's not where that is. Modify, make init cpio.conf, which is where? This here. Okay. So around here somewhere, and I think it's the hooks. There we go. So we need to make sure that LVM is included in here. If we go back to the LVM page, make init CPIO. No. Okay, we're going in here, LVM. Some hooks that may be required for your system like LVM2 encrypt are not enabled by default. Read the hook section carefully for instructions. Which would be over here. That tells us this setup loads, if you look over here, this setup loads an LVM2 volume group, which is what we want. We want to make sure that LVM2 is after block before file systems. can find my cursor here. So we want to insert LVM2 here. I think that's probably it. I've not enabled hibernation yet, but I think hibernation does. Actually, I don't know if it's over here, but that's fine. Yeah, if I didn't mention it earlier, and I think I did, another reason for swap is to be able to hibernate. Without swap, you don't have any place on disk for you to be able to write the memory into. Because hibernation, all that is you're shutting down, but you're saving the state of memory so that you can load it back up later. Windows fast boots is actually just hibernation in disguise. So all that does is it shuts down all your programs, hibernates the rest of the memory writes the rest of the memory onto disk, hibernates, so essentially hibernating, so that when you're back up, it doesn't have to load the kernel again and all that, the rest of the startup sequence. It just reloads that from the save state on disk, and from there, then you can run whatever programs you were having before. So because the system has already started, your startup is faster. I think there might be a way to do that in Linux, but I don't know anyone who does it. But anyway, yeah, so we have our LVM2, make init cpio, which I had learned some time ago that this utility is an Arch Linux specific utility, which is surprising because this is very useful. Alright, so that is there. Then we set the root password. PassWD will change the password for the current user by default, but you can also give it a username to change. In this case, I'm going to hope I remember this. Obviously, I'm not going to tell you what this is. And then we select a bootloader. The bootloader is basically what we get to use so that we can actually boot the system. In my case, I'm using two bootloaders. One is fvstub and the other is grub. Today we're only going to be installing grub because I don't know how fvstub works with this VM. So fvstub here on your machine boot, you have your bootloader, or sorry, your boot options, right? You press sometimes it's F12, sometimes delete, sometimes enter, sometimes another key. But you basically have the option of booting, say, to hard disk, or to a CD drive, or USB drive, or things like that. fvstub here allows you to put your operating system as an entry to that. So you can boot directly to Arch Linux, for example, or if you install it through fvstub. With the other ones, and this is what I have set up on mine, on my PC here, because I only really have the one operating system, and it's mostly almost every time that I'm going to boot the computer, it's going to be to this operating system. And if I ever need to change, I can always go change it. There's no change the selection in the menus. But I don't know how this interacts with the VM, so we're going to skip that. Instead, we're going to install grub, which is also what I have installed here as a backup. for if I need to switch operating systems or anything. Yeah, so we're going to do this through the UEFI systems here. A Grand Unified Bootloader. So a bootloader is basically a program that runs before the operating system boots so that it can boot the operating system. Normally, if you have multiple operating systems installed, you have this bootloader installed so that you can select which operating system you want to boot. So say if you're dual booting between Windows and Linux, you'll often have grub in front as your bootloader so you can select between Linux and Windows. Or if you have multiple Linux operating systems installed for whatever reason, you can also have grub switch between those operating systems. My voice is going to give. I think we might have to end a little bit earlier. I want to make sure I still have a voice for tomorrow and the day after. I can lose it on the weekend, just not the next 2 days. Alright. Installation. So first install the grub and FE boot manager packages. We do that. pacman-s grub and FE boots mgr. We'll install that. Then follow the below steps to install grub to your disk. Mount the FE system partition, which we already have. That would be under what we have under /boot right there. Right. Where's my cursor? Right. Well, it's the first one. It's SDA. It's under /boot. Choose a bootloader identifier here named grub. You may as well choose the same one. And execute the following commands to install the grub FE application. Install modules to that. Make sure to install the packages and run grub install command from the system in which grub will be installed as a bootloader. Already doing that. So that's fine. But all we have to do is run this command here, grub install target x86 64-FE, because this is an FE system. So x86-64 here says that this is a 64-bit system, and the FE here says that it's a 64-bit FE system. FE directory is equal to /boot, and then bootloader ID. Scroll over here. Bootloader-ID equals grub. Okay. And so then that means that we can just run this. No error reported. We see in /boot. We have boot/grub there, but we also have FE boot/FE/grub right there. So this here is our FE application. This is what the computer will run to start for it to load the bootloader. So I can skip all of this stuff. The BIOS system, we don't have to care about that. We have here generate the main configuration file. So after the installation, the main configuration file needs to be generated. And in this case, we can just run this command here. Grub make config-o/boot grub.cg. And this creates the default config by it creates a grub configuration using the default options, which for the most part is fine. We only have one kernel, we only have one operating system, if we look at the list of things that we were going to do, step 2 here is a grub ISO boot. I don't think we're going to get to that today because my voice is going to give out before we get there. But that would allow us to have, that would allow us to show off grub and have it show multiple boot entries. That would be this one here. But yeah, we'll leave that for another time. Let's get this thing installed first and then get it booted. And then we're probably going to end it there. Yeah, custom menu entry is there. It's fine. We'll do that when we get to the ISO boot thing. And that, but otherwise, that's it. That is grub installed. So that is our bootloader. And then we just reboot. So we exit the chroot as it says there. Now we're back in the installation medium's shell instead of our local environment there. umount -r/mnt, kind of redundant. We don't actually need to do this, but it could be safer to do. It doesn't hurt. And then it says here, type in reboot, and we'll get reboot. So with any luck, we will get a working system once we enter. All right, so here's hoping it works. Cross your fingers. So this is grub. That's good. That's a good sign. All right, we got our RTM login. Now we can sign as root, and then we have a root login. All right. So now we can look at this post installation stuff. General recommendations. Users and groups. We want to create. So we don't want to be in our system just as root. Root, if you're not familiar, is basically the super user of Linux. It can do pretty much absolutely anything. So you don't want to be going around with all that power. So normally what you want to do is you create a user for yourself. That's what we're going to do here. User add -m-g. Create a users group. Wait, we don't have one yet. It's fine. We don't need to change the login shell. So we have your user add -m to create a home directory, and then -m, or sorry, and then my name for this Penbu as my username. And then I want to change the password for this, like so. And I want to change it specifically for the Penbu user that we just created. Okay. And then that is fine. Security, we want to make sure we have sudo. So sudo allows us to have privilege escalation. So it allows us to have, what is it? It allows us to run privilege commands that would normally require root access, but as a regular user. So for that command, it grants you the powers of a super user. Or depending on how you call it, it might grant you the powers of another different user instead. But by default, it's the root user. In this case, we're going to install sudo. Pacman s sudo. I can't believe this. This is already it's already out of date. Give me a reflector. So reflector, and we skipped over this portion. Maybe we shouldn't have. Pacman S reflector. We're gonna install reflector. You know what I think it is? We might have missed something in our network setup. So as always, whenever I reboot a system and reboot an Arch Linux installation for the first time, network always fails. Seems like this is not an exception. If we go back to our DHCP-CD thing, so somewhere around here, I think we actually needed to enable a service. Welcome in, Takada Harunobu. Another Archdetrio. How do I pronounce that? Thanks, cutie. Well, thanks for the head pats. But yeah, we just finished going through the installation guide. Now we've rebooted into our system and our network isn't working as normal. So we are just getting that up and running. And I think the problem is that we needed to enable the service for DHCP-CD. So it says here to start the daemon for all network interfaces, which is what we want to do. Start or enable this one. So services in Arch Linux are managed by this program called systemd. It is somewhat controversial, or at least it used to be a little bit more controversial back in the day. But I think the majority of Linux distros these days have moved over to systemd. Personally, I don't have an issue with it. It seems to be fairly clean. I think people are saying, people have, the reasons people have it against it is that it's doing too much, and to an extent I do agree. It does a lot, but it's also kind of convenient. Lucas TA, welcome in. Oh man, I don't even want to know how to set up Archie on VM. It's actually not that bad. It's mostly the same, and actually simplifies things a little bit, because then you don't have to deal with, well, I was going to say you don't have to deal with networking, but clearly we're dealing with networking here. And then if you're in VirtualBox, there's also a package for the guest utils that you can just install instead of having to install it through the ISO. So it's fairly convenient. Which reminds me, we need to install that here too. But yeah, in a VM, fairly simple. One thing that I did overlook here, because we were on my regular system that I'm using right now, I do have Arch booted through festub, and then I have grub as a backup. But for the VM, because I don't know how festub interacts with the VM, I'm just installing it through grub. Plug in the cable in DHCP D just works. Yes, except you actually do have to enable the thing first. So we're going to do that. Systemctl enable now dhcpcd.service. I actually don't know if now, I don't trust that because sometimes it doesn't. So we're going to start that. The earlier comments, keep showing the good job there. Good luck. Thank you. Okay, so now with DHCP enabled, we can hopefully just ping this thing and it should just work. Alright, we got it pinged. Yeah, the Wi-Fi. Don't get me started about Wi-Fi. I think for every Arch Linux installation that I've had, I've used a different network manager. So in my first Arch Linux installation back in 2014, I had used just raw WPA supplicant. And I had to do that while installing Arch Linux on the Edgeroam network, which is an enterprise WPA2 network. So that involves getting certificates offline and then configuring up your username, password, all sorts of headaches. And then, because I was in university at the time, and that was the only Wi-Fi network available. And then I graduated and got another laptop. Ended up using NetCTL for that one. Fairly easy, fairly straightforward. And also only had to connect to a home Wi-Fi network, so all you have to deal with is SSID and a pass key or a passphrase, and that's it. I don't have any specific attachments to NetCTL, but it is a little bit easier to manage, I think, than WPA supplicants, but not significantly so, I think. For some reason, I have an aversion to Network Manager, although I think Network Manager would make things a whole lot easier. For my PC here, the streaming PC that I'm using, it doesn't need to connect to Wi-Fi at all, so all it has is DHCP-CD. And then that's also what we're using for the VM, because it also doesn't need to deal with Wi-Fi. All it is, it just needs to go through Ethernet. Yeah, and for WPA supplicant, at least there's the GUI for it. For NetCTL, like, I don't really mind not having a GUI, but it is nice to have something to click on quickly so that you can check which network you're connected to. I don't actually know how to do that in NetCTL. I'm sure it's in there somewhere. Pretty simplistic with your networking, to be fair. Yeah, for me, I think I had to, well, even then, I think, did I deal with VPNs? When these days, so I have Mulvad as my VPN, but I worked through that using WireGuard, so it's a little bit easier. Back in university, I think there was another VPN that I had to use for the university to get into certain resources. But also, I think that wasn't too bad because that was a separate program too. Yeah, anyway, I know Network Manager makes things a little bit easier to work with, but I don't know. For me, I find that I just tend to avoid Network Manager for, well, maybe because it's too large or something. Yeah, nothing too complicated. Okay, so yeah, we have that now. So now we can install the stuff that we wanted to install, which was Reflector. And we also wanted to install something else. Vtuber, right. So Reflector will keep our mirror lists up to date. Our ships with reflector.service will run on specified parameters in this thing. Actually, I'm just going to copy over what my current config is. I'm going over to the real system here. reflector.conf. I think the important thing here is port score, what I have there. BG reflector.conf. Sort the mirrors by score. We're going to get rid of that. We are also going to get rid of the latest one. I think we want all of them. And the rest of that aside. Sort the mirrors by score. Sort score. Okay. That's fine. And we want to enable the reflector.service. Actually, we want to enable the timer so that it runs weekly. Not that this VM really needs it, because after this stream, we're probably not going to boot it until the next stream that we do this in. There will be a follow-up, by the way, because we had all this stuff on our list, and we've only gotten through this bit. and my voice is starting to give. Normally I'd be able to last for about 3 hours, but it's a lot of talking involved in the stream. My throat wasn't in a good spot to begin with. So I want to make sure I don't lose my voice, because we do have more streams coming up the next couple of days. So yeah, we're gonna have this timer. So systemd not only has services, but it can also run those services on a timer. It's kind of like cron in that way, but internal to systemd. So in this case, it's set up to run weekly. So system ctl enable reflector timer. Actually, I'm also going to install bash completion, I think it was, so we can tab complete these things. Start reflector.timer. Okay, so that should go as it needs. What else is here? Okay, so I think that's it for reflector. Sudo, we need to configure that. Sudo. So we've installed the sudo package. And so, as I said earlier, sudo allows us to run commands with elevated privileges while still being a normal user. vi sudo allows us to edit the sudo config file and do so safely. Actually, hold on. Before that, I'm going to create a group called wheel. It's a group adds wheel, I think. Oh, it already exists. Okay, that's fine. I guess it's already made by the system. So vi sudo. No editor found. Okay. Well, I would like to have vi too. Just, you know, for POSIX. Export editor equals vim, but we do have vim available to us, so we may as well have vim there. Okay. So this here we have the sudoers file. This is the configuration file for sudo. It's very important that you edit this not directly, but instead through vi sudo, so that if something goes wrong, it doesn't mess up your sudo and lock yourself out. For the most part, this is actually fine. I do tend to like having the wheel group have access to it, access to all the commands here. And for a single user system, I do prefer to have this too. Where instead of typing in your own password, which is what sudo does by default, it asks you for the password of the target user that you're trying to impersonate. In this case, you would have to know the password of the root user. For a single user environment, or for a single user system where you're the only user, this can potentially be more secure, because then an attacker may know your password, but they might not know your root password. And if you have sudo enabled, then it allows, if you have the default setting, then as long as they know your password, they have root access. But if you have this enabled, where you have to have the passwords enabled, or you're getting sudo to ask the password of the target user, then they need to know your password. There is something here though that says, warning, use this only together with defaults target PW, which is what we have somewhere. Target PW, where is it? This one. Uncommon to allow any user to run sudo if they know the password. Yeah, actually, we just leave that off there. Default's target PW here. Just the root password then. Yeah, so if you have target PW enabled, then what it does is instead of asking for your password, it asks, in this case, for the root password. Something also that I also like to have here, insults. This is an Easter egg that if you type in the wrong password for sudo, it throws insults at you. Okay, so that should be good. And now that it's written, it didn't complain, so that means that the configuration file is valid, and so we should be good to go there. That's fine, we don't need to deal with any of those. Go back to general recommendations. So now that we have sudo, we want to add our user to the wheel group. Like so. So now we have the ability to use sudo. Other people might want to consider using the sudo group instead of the wheel group. I like using wheel because I think it gives me it gives you a little bit more access to some of the more administrative parts of the system. Wheel is basically the system's administrator group in some form. I don't know why it's called wheel. I think there's some history behind it. At the same time, maybe that's less secure than it should be doing, but oh well. So security, that's what we have there for sudo. We have service management here. That's going through how to use system D and systemctl, which we had in there. System maintenance, this is a matter of like updating every once in a while, which we're not going to cover this stream. Package management, build system, that's all stuff we don't really need. Graphical user interface, I guess it would be nice to show that off here. Okay, so now that we have a user that has sudo privileges, we're going to log out of the root user because we want to minimize the amount of time that we're on there. And log into our user. And then we can install stuff through sudo and pacman-s. In this case, I still tend to prefer to stick to Xorg. I know Wayland is newer and it's up and coming. And it's probably stable enough for general use, to be honest. But there's still stuff keeping me on X. That's particularly this window manager that you see here, WMII. There are some efforts to port it over to Wayland. They're not quite ready yet. Okay, so we're in driver installations. Actually, do I want to do this now? I want to strain my voice more. Man, the times I moved my home as root and had to chmod ch on everything. Oh yeah, that's certainly an endeavor. Okay, actually, you know what? I think I'm thinking, do we want to do the ISO boot now? Because it is actually fairly quick. Or do we want to set up a graphical session? I think a graphical session would be a good thing to end on, though. I get permissions right for SC GPG stuff. Yeah, that's I'm still trying to figure out my GPG setup. Because I don't want my private key on this machine. But if for some reason I end up running something, and because this is the streaming machine, that there's a little bit more surface area for things to go wrong here. So I want to make sure that my private key is stored on a different computer, which involves setting up like delegate keys or something. I just haven't had time to sit down and and figure that all out. Actually, maybe we can probably do both. Okay, so let's try getting X out since we're already here. All right, so we're gonna install Xorg server, Xorg apps. Actually, we can just install the entire Xorg group. Which this, right, so we have here, right, the first couple times you run sudo, it'll give you the spiel here, basically saying that this is a very dangerous command, and we trust you to receive the usual lecture from the local system administrator. I guess I've given myself that, yes. It usually boils down to these three things: respect the privacy of others, think before you type, and with great power comes with great responsibility. For security reasons, the password you type will not be visible. Sudo password for root. Just to show off the insults here, I'm going to type in a bogus password. It can only be attributed to human error. I think sudo allows us 3 times before it gives up. When you're walking home tonight and some homicidal mania comes after you... Where's my cursor? With a bunch of Logan berries, don't come crying to me. Threatening. Oh, I didn't do it for the other one. I'll do a bunch of other ones. Just to see more insults. You silly twisted boy, you. I wish to make a complaint. You know, I think sudo used to say that, what was it? There's the one XKCD comment that referenced this. Oh, no, the sandwich one is fine. Incidents. I'm going to go to the actual comic here. Move this over here. Sudo su, password robm is not in the sudoers file. This incident will be reported. I remember seeing this, and I don't think I've seen that on Arch ever. So maybe it's an Ubuntu thing, or maybe they took it out. Hey, who does sudo report these incidents to? You know, I've never checked them. We have Santa here. The alt text, he sees you when you're sleeping, he knows when you're awake, he's copied on varspool mail routes, so be good for goodness sake. They removed it, I see, okay. Yeah, I actually don't know where it's where it logs it to. I think it would make sense that it's probably somewhere in varspool. So the varspool would be the mail file. Or it might have been in some log file or whatever, but even when I did see this, I think, did anyone ever look at it? And then people know the sudo for the sudo make me a sandwich thing. Proper user policy apparently means time set. Okay, let's actually type in the right password here. Dmessage or journal probably. Yes, the system journal is more likely. Dmessage, I think dmessage is more for hardware, isn't it? Yeah, system log. All right, so these are all the packages that we have in the Xorg group. We may as well install all of them, because I don't want to think about it. But also, while we do that, we also have this graphics card thing. We are inside of a VM, so maybe this is all taken care of for us. lspci/-v grep a1 evje3d VGA compatible controller VMware SVGA. This is probably fine, to be honest. We're also going to install XF86 video, which may or may not already be installed here, which doesn't look like it. Okay. Actually, there is another page here that I should probably look at. VirtualBox. Because it has a thing here for Arch Linux install as a guest. We install in FE mode. We've not installed the guest editions, which we will do now after we install all this. All right, this is outdated. Oh wait, no, because it says search for it. That's fine. Yeah, have all that installed. In the meantime, we can read over this. So we'll want the guest utils with X support. So sudo pacman-s virtualbox guest utils. All right, and that installed our XF86 video VMware driver that we needed too. So this is great. And then from there, I think actually we're ready to. Oh right, we also need Window Manager. So I like. If I'm not using WMII, which I'm not going to be installing in this VM because I don't want conflicts, I like to install IceWM. IceWM is a very lightweight window manager, very simple window manager. And so we are installing IceWM here. sudo pacman IceWM. And so I think we may already have X in it as well. Hopefully. Oh, we don't. Okay, so we have to install that too. So, no, with other distros, you get all this stuff out of the box. Most distros will have a graphical user interface for you booted in already. Arch gets you to install that yourself, but then it does mean that you get exposed to a lot of the what goes into a graphical session, or at least making one appear. The reason it doesn't give you one by default is because Arch can be used in server situations where you don't need a graphical session, and so it doesn't want to assume things for you. I'm also going to install those dependencies. XOR TWM, which is another window manager, xterm, and I'm also going to install a better terminal. So xterm is the X terminal, but I tend to like using urxvt if I'm in IceWM, because it's a bit of a nicer terminal that's still fairly lightweight. RxVT? Okay, what is this thing called? Terminals, where are my terminals? I have it installed on this one. urxvt. Hold on. Pacman Q or SSRxvt. Ah, RxVT Unicode, I see. Okay. So we have the things that we need to spin up a session, and then a bunch of nice utilities here. I'm also actually going to install Xeyes, because you always have to. All right, so At this point, you can install a desktop manager, and that will allow you or that will spin up a graphical session as soon as you start the computer. I tend not to like to do that. I tend to prefer to drop to a console first, like virtual terminal, log in through the console, and then use startx to actually start the graphical session. And the reason I do this is because it means that there are fewer things. There's less surface area for things to go wrong. So if I need to get in right away, or if I'm restarting a bunch of things right away, there's not a lot of things starting up, and I can be in control of what is starting up. Using the .profile, just log in TTY. Yeah. So we have startx here, which IceWM session. So this here starts a graphical session from this TTY here. That is not IceWM session. That is TWM. Hold up. Let's move this over. It's actually the first time that I'm going to resize this to 100%. The first time I had encountered TWM, it was at a university computer. I didn't know how to use it because it didn't come with these windows here. Like, it was all just a blank screen. I thought it was actually broken. But no, TWM is actually fairly usable if you know how to use it. I just don't like to use it. It's fine. It works. Okay, we're gonna exit out of that. It's right there though. Oh, I don't have the witch command, that's why. Yeah, I'm gonna install a witch too. Okay, I'm gonna make that a bit okay. So startx, witch IceWM session. Which should give us the IceWM session. I mean, it looks pretty awful when it first starts up. And we do need to install a bunch of fonts here, but this is a graphical session. Settings, themes. I personally like to use the Metal 2 theme, which is... I'm going to start a terminal here, or maybe something else. Text editor, Vim? Oh yeah, okay, so install gvim. Interesting. But yeah, the Metal 2 theme is based on the Java theme of the same name. Metal, I think, was used in Java 4 and earlier. I think it's still available in Java. You just don't see it around very much. I actually haven't kept up with... the last time I used Java was Java 8. And now we're on, like, Java 22 or something. There's been a new graphical framework that's been made since then. 2 of them, maybe even. But yeah, this here we have a graphical session. Works fairly nicely. IceWM is nice. Yeah. So this works. And I think we can say we might have time for this grub boot thing, and we're going to end it there. So recap, we've installed Arch, and we've set it on top of LVM, btrfs, and we installed grub on it. And we have now a graphical session running IceWM that we can do stuff in if we wanted to. We're going to make this larger. The next thing we're going to do here is... Actually, maybe we should save this for next time, because if we have this here, this isn't going to take a lot of time. It would have been for the stream. Would have been enough for like a 3-hour stream, but my voice is going to die soon. So actually, yeah, maybe we'll leave it there. And save these two for next time. in which case I'm going to show this so that we have a good snapshot to end on. What programs do I have in here? Yeah, I mean, I guess we can put the stuff that we had before. We don't have any programs installed really. Oh, Neofetch. Yeah, Neofetch. That's a good idea. But we do have to install that first. Maybe Pacman S Neofetch. Well, actually, I heard that Neofetch became deprecated. I think the original author had archived the repo or something. I don't know if the community's picked it up, but surely they have. Display images is fine. Image text support, that's fine. Yeah, we don't need that. Fast fetch, I see. X2 tool. This is probably fine. We need to install fonts because this is absolutely awful. We can put that over in the corner. And then what else can we put in here? There was something else. There was something else I was going to put. All right, excise. Excise. Because you have to. H-top. Yeah, I guess we can do that too. Open up another URXVT thing. Move the eyes over. So excise actually does have some practical use. Apart from being all silly, if you have a couple of them positioned in corners, it can help you locate where your cursor is, and that can be useful if you're doing a presentation or something. So let's say I have one here, right? And I have another one here. Put those in the corner, and then you can tell just by following the eyes where my cursor is, or like at least have an idea of where the cursor is. It finds X windows in Wayland too, yeah. I can't say I've used Wayland in any good capacity. I know there's been some weirdness with how the X windows interacts with Wayland, and for things like excise that require certain X functionality. But yeah, I think if I'm not mistaken, excise doesn't work on Wayland windows, but it does work if you're over an X window or something like that. Right, you said HTOP, which I do not have installed, and I should install that. HTOP is very useful. I'm not going to show it on my main system because I think that reveals too much information. But it's very good as essentially a task manager. Yeah, so we only have one CPU on this VM, more than enough, and 1 gig of memory, I think, plus a gig of swap. Let me move this over here. And actually, to show off another thing that we did, I guess we can put in this block F here. Like that, I guess. Okay. I mean, it's kind of hard to see, but there we go. We have a graphical session up. We did a bunch of stuff with LVM and btrfs and Rub. Yeah. I mean, I don't know what else to say here. We've installed Arch Linux, and now we can use it. There's still a bunch of things that we could do here, like install fonts. Did you make it here just in time for the end? Yes, you did. We do have the graphical session up. And we do have, so we got up to here. And I think because my voice is dying, we're going to leave the other two for later. for another stream. But the VOD is going to be up, so if you really wanted to, you can always go through and scrub through it yourself. I would say that we didn't do anything too special, but we actually did stray away from the installation guide a fair amount, just to make sure that we have all these stuff here. But yeah, this here is our layout. It is very similar to what we have in my current one. Else block. Although my current one, like my actual one, is a fair amount more complicated. What we were going to do this stream was set up these two discs, which you were actually there for, in that one Discord stream that we did. But we were going to do that as step 3 here, set those up as separate disks and join them together as LVM RAID1. But that'll be for another time. If you have any suggestions, or rather any of you, if any of you have any suggestions for what we might want to do with this piece or with this VM, let me know, because I don't think these two items are going to be able enough to fill a stream. So we might want to do some other stuff in addition to this. All right, I think that's it. I need to rest my voice. Next stream, I can get the next stream window up. We are going to be playing Natas, which is the over-the-wire war game for web security. I don't remember if I played this before. I think I might have, but it was a very long time ago, so this is effectively new for me. I am a web programmer by profession, more or less, but I don't deal with web networking or like web security networking and all that, because this is a lot of the server-side stuff. I did take some security classes in university, so I know a fair amount, but this should be fun. Going around and hacking a server, and just to go over the rest of the week here, I do have this this window somewhere. Is it over here? Sorry, I'm just looking for the thing. Okay, I can always just go to it. vt.c/schedule. Hide this window here. We do have the website for the schedule. So today was the Arch Linux VM install. And as I said, this week is Technical Debt Repayment Week, because we've been lacking in a lot of technical content over the past couple months, and so we are jam-packing this week with a lot of technical content. Can't be the programming, puzzle gaming, music making, VTuber without the programming portion. So yeah, tomorrow is Natas. We're just going over web security. Now on Friday, we are going to be implementing cat in Pure Bash. This is a tutorial, so you're free to follow along and program with me while I go through and explain in detail what everything is. I am going to try to assume no prior knowledge, so hopefully it'll be easy to follow along, even if you know nothing. And then we are going to end the week off with Tetris 99, because there is a new event coming up. So even if it's not technical, we do have a new event coming up over the weekends, and I would like to get that theme. Okay, yeah, that is the schedule for this week. If you can't remember that, I can always go to this website, or you can join the Discord, where I post the stream notifications there as well. Stop. Never know how to end these things. But yeah, so next stream is this. Watch out for it. It's going to be 7:30 Eastern. So same time as this stream here. Should be fun. Okay, I think that's it. Thanks everyone for coming. For those of you on Twitch, we're going to find somebody to raid. For those of you on YouTube, as usual, we're just going to end. And for those of you who are new, my name is Penbu. I'm the programming, puzzle gaming, and music making VTuber on Linux. This has been Arch Linux installation, and we'll see you next stream. Bye, chat. Alright, for those of you on Twitch, I'm still looking for something to raid. I'm between somebody who is doing math and showing us differential equations, or somebody who is designing a game. Both of them VTubers. Oh, did you just end? I think you just ended. Never mind. Okay, I guess I'm going to look at math then, in that case. Anyone else here? Yeah, okay. Yes, okay. We're gonna set that up. This is the raid message if you'd like to participate. Go say hello, enjoy the math. Well, we'll see you next stream. Once again, good night.